Many countries within Europe do have their own space agencies. In fact, Spain's National Space Agency, INTA, was founded in 1942 and still operates to this day, making it one of the oldest space agencies in the world. These individual space agencies can select astronauts and some have satellites, but separately, none of Europe's economic powers can compete with the Russian and American space programs. For that reason, in the 1960s, Western European nations founded the European Launch Development Organization and European Space Research Organization, a precursor to the European Space Agency established in 1975. The European Union wasn't fully established until the Maastricht Treaty was signed in 1993, bringing with it other exercises in cohesion like the development of the Eurozone. While the EU was formed after the end of the Soviet Union in 1991, ESA was, in a lot of ways, a direct response to the Soviet Union's existence. Western European countries were the founding states of ESA, situated squarely between the USSR and the USA on the other side of the Atlantic. It was through ESA that the European bloc was finally able to start investing in space, and it's seen a lot of successes. Since the dissolution of the USSR, many of its former states, now sovereign, are also members of ESA, further strengthening the organization. More member states means more scientists, more missions, and most importantly, more funding. And in fact, though the Russian space agency Roscosmos is still a world leader, ESA now has almost double its funding. In fact, after NASA and the China National Space Administration, ESA has the third biggest budget of all space agencies globally. On top of that, the national space agencies of France, Germany, Italy, and the UK are all in the top 10 space agencies for budget as well. The reason ESA needed to exist was that lots of scientists from Western European countries weren't staying in Western Europe to work in the far smaller space agencies of individual nations. With the US and Russia making leaps and bounds after the Second World War, the allure of going further west or east to work for NASA or the Soviets was too strong for many researchers. ESA was an alternative that quickly proved itself to be an enticing option for the growing field of space exploration. And just like the US and the USSR, European countries were also developing warheads and rockets to build up their own nuclear arsenals. Nuclear research in Europe was already using this unified model following the establishment of CERN, the European Organization for Nuclear Research, all the way back in 1954. CERN has given us incredible scientific advancements like building the Large Hadron Collider, the world's biggest particle accelerator. With this invaluable experience, there was no realistic way ESA could fail. Ever since its official ratification in the 1975 ESA Convention, ESA has been a credible and important space agency. Its first mission was the COS-B space probe, a satellite that monitored cosmic gamma rays. COS-B was launched in August 1975, only months after the ratification, and was a success. It was operational for 6 years and taught us a lot about cosmology, an incredible first mission that firmly put ESA in the major leagues of space exploration. Other organizations were lining up to collaborate with or join ESA as soon as it proved itself a worthy organization. In 1978, ESA collaborated with NASA and the UK's Science Research Council to launch the International Ultraviolet Explorer, a space telescope that remained operational for the better part of 20 years. By the early 80s, French aerospace company Arianespace was formed to build ESA's launch vehicles, which it still does to this day. ESA was also hard at work developing concepts for Spacelab. A major collaboration with NASA, Spacelab modules built by ESA were used throughout the Space Shuttle program. ESA also plays a major role in modern space travel thanks to its Astronaut Center, with European astronauts selected and trained before going on to work in joint missions. The first ESA astronaut was a German named Ulf Merbold, who went into space in 1983 on the STS-9 mission, and who became the first non-American astronaut on a NASA mission. Another big success from ESA was the Bepi-Colombo mission, launched in 2018. A joint mission between ESA and the Japan Aerospace Exploration Agency, Bepi-Colombo is en route to Mercury, set to arrive in 2025. But it hasn't all been smooth sailing. ESA has had its fair share of failures, too. In 2005, their Cryosat satellite was destroyed due to launch failure. The launch vehicle's flight system failed to cut off its engine, and once it ran out of fuel, it crashed down in the ocean near the North Pole. More recently, 2 of Arianespace's Vega rockets failed in 2018 and 2020. Though these rockets weren't carrying any people and nobody was hurt, they were an enormous expense, with the 2020 launch carrying 2 valuable payloads from Spain and France. Having said that, ESA actually hasn't had anywhere near as many failures or high-profile disasters as NASA and Russia, which have both seen many tragedies during their space programs over the decades. ESA's celebrated history is certainly impressive, but what does the future hold for the organization? Well, there's a lot on the horizon for Europe. One of the biggest missions currently going is the astrobiology program ExoMars, a joint operation with Roscosmos. In 2016, the first stage of the ExoMars program was launched, the Trace Gas Orbiter, which is studying the composition of the Martian atmosphere. Sadly, its lander crashed into the surface due to the premature release of its parachute. But a new lander is set to launch in 2022 to deliver the ExoMars rover, named the Rosalind Franklin. Once on the ground, the solar-powered rover will hunt for morphological and chemical traces of past life on the red planet, relaying data via the Trace Gas Orbiter. It's designed to navigate autonomously using a 3D map of the terrain. The program should provide invaluable research ahead of the inevitable manned missions the next decade will bring. ESA is also signed on to play a major role in constructing the Lunar Gateway, a space station that will orbit the Moon just like the ISS orbits Earth, enabling more manned lunar missions in the future. ESA is going to be designing one of the modules used on the station. The plan is to start launching the modules in 2024. There are hopes that the station will be key in exploring and perhaps eventually colonizing the Moon, Mars, and other areas of the solar system. In yet another joint mission with NASA, ESA will be designing a spacecraft named Hera for the Asteroid Impact and Deflection Assessment. Launching in 2024, Hera will study the impact of a space probe that's being deliberately rammed into an asteroid moon. That might sound like a bit of a spurious aim, but it's part of a broader investigation into what we'd do if we ever discovered a large asteroid on a collision course with Earth. In the meantime, we can look forward to the launch of the James Webb Space Telescope in 2021, a joint project between ESA, NASA, and CSA. The telescope will succeed the long-lived Hubble telescope and allow us to see even deeper into the vast reaches of space. Researchers hope to learn more in particular about how the first galaxies formed. It's clear that ESA has a bright future, and that Europe is going to keep researching space for the foreseeable future alongside the other Big Six space agencies. The European bloc remains a hugely wealthy and powerful part of the world that has long prioritized cohesion and unity. ESA is just one example of this, and since its creation, it's been wildly successful. And that's why the European Space Agency could be the next space superpower.